Okay, guys, in this video, we're going to kind of quickly talk about the metric system. The metric system is pretty cool because it's based on powers of 10, so that it makes it easy to convert between the units of the metric system. So here are the most common ones we hear, and you can see kilo, hecto, deca, unit. This has changed our little mnemonic device to say unusually, and I'll talk about that in a second. Deci, centi, and milli. Deci is just abbreviated with a D. Deca would be a DA for that. So this does say King Henry died unusually, because this is the units place, and the units could be meter, and then it would be called a kilometer. It could be liter, and then it would be called a hectoliter. Or it could be a gram, and it could be called a decagram. Length, liquid amount, and weight. As you can see here, it's telling you that if you're moving from a smaller unit to a larger unit, you will be dividing by powers of 10 as you go. That should make sense. If I have like 5,000 grams, I should know that that's only going to be 5 kilograms, considering there's 1,000 in each kilogram. So I should know that I have to divide. If I have 1 kilogram, and I'm wanting to know how many milligrams, that is, I should know that I'm going to have a bunch of those tiny units to equal this gigantic unit. So I'm going to multiply. I'm going to show you guys on the next slide a powers of 10 chart, just so you guys understand what I'm talking about there. So some people have asked me multiple times in my teaching career, what are the numbers past trillion? Well, it is quadrillion and then quintillion, which is pretty cool. I also thought this was pretty awesome over here, the fact that a lot of times we don't know what comes next after the kilogram, but it is mega, giga, tera, peta, and exa. Tera should make sense to you guys because of terabyte. Giga should make sense because of a gigabyte, and mega, again, a megabyte. So here we are in the powers of 10. 10 to the 0 does equal 1. That's one of those things you need to understand. 10 to the first is 10. 10 to the second is 100. As you guys can see, this exponent equals the number of zeros here in the common notation. This can also be called standard form. When we get down to the negative exponents, this is putting that number behind the decimal. That 1 goes behind the decimal the amount of times of the negative exponent. We're going to talk about this more mathematically speaking in a unit in the future. But as you can see, -2 has the 1, 2 places behind the decimal, 3 places, and so forth. I love that we go 1 millionth, 1 billionth, 1 trillionth, 1 quadrillionth, and 1 quintillionth. And again, I love how over here it takes us past the milligram and goes to the micro, the nano, and everything else. I'm sorry, I clicked to this next slide, so we're just going to quickly talk about it. So I have 6 kilograms. So I'm always going to start on the chart with the given unit with this other guy as my goal. So 6 kilograms, I'm going to come over here and see it takes me 1, 2, 3, 4, 5, 6 hops. So that means I'm going to end up adding 6 zeros to get it to be in grams. So that means 6 kilograms equals 6 million milligrams. But what I actually did is I multiplied 6 times 1 million because it takes 1,000 of the units to make 1,000 milligrams to make 1 unit, and then another 1,000 of this unit to make 1 kilogram. So that means it takes 1,000,000 milligrams to make 1 kilogram. So 5 milligrams to grams. Again, here I go. I'm going to go 1, 2, 3 hops, and I'm going from a small unit to a large unit. So that means I'm going to end up doing division. And where I get this dividing by 1,000 from is it takes 1,000 milligrams to make 1 of my unit. So 5 milligrams equals 5 thousandths of a gram. I put grams. It's always a common thing to put the decimal in. Again, let's look at 3.6 kilograms. Here I am. I'm going to start with my kilo. I move 1 unit. That means I'm dividing. I am multiplying by 10. I'm sorry, I said division there. Multiplying by 10 because it's going to take more of this smaller unit to make this bigger unit. So what I did here is I know that it takes 100 hectos to make 1 gram. It takes 1,000. So 1,000 divided by 100 is 10. That's where I got this index of 10 in my more mathematical approach. So the answer is 3.6 hectograms. 36 hectograms. I'm not sure why I'm bumbling over these words. For some reason, even though the metric system is very easy, it makes me nervous. I guess I'm just more used to our standard system, but it really is pretty easy to change stuff. I don't like you guys just depending on this King Henry died Monday or died unusually. It was Monday, but unusually is what it's been turned into because this is the units. Drinking chocolate milk. Another one that I've heard is King Henry did not usually drink chocolate milk. I thought that one was pretty interesting too, because again, this is a unit. This can change names. So 300 liters. So let's start at our unit, and I'm trying to go to deci. We know it's deci because it's just a D. If you look back at that previous slide, if it was deca, it would be DA. So here we are. I am starting from my liters. I want to know deciliters. It's going to take more, so we know we're going to be multiplying. And then again, so I multiplied by 10, and I got 3,000 deciliters. 3,000 millimeters equals how many meters? So again, we know that we're going to take 1,000 of these millimeters to equal 1. So we're just going to take 3,000 divided by the 1,000 and get 3 meters. Again, that's the mathematical way. On the chart up here, we're starting at the millimeters, moving 1, 2, 3 places. So that means I'm going to move my decimal 3 places, and I get that 3 meters. I just wanted to quickly kind of chat through this mathematical approach. You can look at the powers of 10. Kind of the shortcut approach is just thinking about how many times to move your decimal, because we should know that multiplying by 1,000 moves our decimal 3 places to make it bigger. Dividing by 1,000 moves it 3 places to make the number get smaller. Again, I really love this powers of 10s chart, just that because it gives the names, and then also just you knowing that these, it takes, like if I were 1 gram, it would take 1